Kia ora, Year 12. This is a really short video for Sahisnu, and it's an inverse trig integral where we've got some really messy constants, so it's a good one to do. Now, apologies, my touch screen stylus has just suddenly stopped working for the night. It's probably sick of doing videos, so I'm going to be doing this with a bit of finger painting, but hopefully it'll work. So what you should recognize when you see this integral is that it's going to be some kind of inverse tan thing, right? Because we know that our basic integral of 1 over 1 plus x squared dx is equal to tan inverse of x plus c. There, oh, sorry, this is really painful with no pen, but I'll keep going. Okay, so we get that far. So we can see that this is somehow related. So what am I going to do first? Well, I'm going to take that 6 out of the front, and we'll start with that. So we'll clean up the constants as we go. So this is equal to 6 divided by 1 over x squared plus 3 dx. Now, I don't want x squared plus 3. I want x squared plus 1. So I'm going to do something like what I did back when we did the binomial work, where we forced it into the right pattern. So we're going to have 6 times the integral of 1 over 3 times 1 plus x squared over 3 dx. And now it suddenly gets much more obvious to spot the pattern that fits with the tan inverse. And again, I'm going to take this constant here out the front. So we'll get 6 over 3, which gives me 2 times 1 over 1 plus, and this thing here is x over root 3 squared dx. Now there's a couple of ways I can go here. I can start to do some backwards chain rule in my head, and if you're a confident student, that's fine. But for most students doing this problem, it's probably going to be safer at this point to do a really easy little u substitution. So let's do it that way. So we've got let u equal x over root 3. So du by dx is 1 over root 3. We know we're going to have to replace this, and we're going to have to replace this. So let's get an expression for dx in terms of du. So dx is equal to root 3 du. And now we're ready to do those substitutions, right? We're going to substitute u in here, and we're going to substitute in root 3 du here. So what this does is it safely does the backwards chain ruling stuff for you. So we'll just shrink that down a wee bit. So this now equals 2 times 1 over 1 plus u squared times root 3 du. And you can see that we can take that root 3 constant out the front. So we get 2 root 3 times the integral of 1 over 1 plus u squared du. And we don't even need to, we do need to substitute back in the u, but it's very easy. So that gives us equals 2 root 3 times tan inverse, and instead of u, I'm going to write it as x over root 3 plus c. So there you go. If you are not confident with that after one example, then you could make up a few others and give them a go. And there are some lovely integral calculators on the internet that will do the integration for you and show you all the workings. So I'm just going to quickly show you one of them in case anyone is still watching. So the one I just found was this. It's called Integral Calculator. Calculate integrals online with steps and graphing, and it is really, really cool. And so I just checked my work on here, and you can see that down here it does it, and it will even show you the steps. So there we go. It's done a u substitution, right? So a slightly different way from how I did it, but basically the same thing. Okay, just keep on emailing me, guys, if you've got any questions. Sahisnu, thanks for sending that one in. I'm sure there are heaps of people in the class who will find it useful.